My name is Liam Pilarski. My partner Aryan Dugar and I have worked tirelessly for over 24 hours to bring you our project, AIDistance. The main premise of AIDistance is to provide an accurate count of the number of people in a given facility using camera footage analyzed with the help of machine learning. Inspired by the issues surrounding the COVID-19 pandemic, this concept is meant to be an asset to social distancing. With a quick visit to our website, people can quickly see which locations featured on the website have a greater concentration of people, and thus which locations present a higher personal risk should said person choose to visit that location. The website we designed that presents and organizes this data will be covered in depth in another video. In this video, I will be discussing the machine learning component of our program that allows us to gather this information. Let's talk about how we obtain data. We use the Inception v2 COCO model from TensorFlow's Zoo library to detect humans from a live video feed obtained using OpenCV's video capture function. Information about number and positioning of people in each captured frame was provided to us by the model in the form of coordinates for bounding boxes that outlined each person's location in the frame in response to an input of an image tensor. Several issues were encountered and overcome throughout the process of designing this program. When we first implemented this model, we had difficulty providing an accurate number of entities in a given frame because oddly, the model would sometimes classify an individual arm or leg as a separate human being, outputting two bounding boxes for a single person, and thus skewing our data output. This was fixed with a calc overlap function that we created with the help from NumPy that gave us an accurate idea of whether an overlap was erroneous, depending on the relative sizes of the overlapping bounding boxes and the percent overlap between the two bounding boxes. The nearest neighbor class from sklearn is incorporated to cut our comparison time down by guiding our search for suspect pairs of bounding boxes, allowing us to selectively compare in order those that are most similar to each other in both size and location. Another issue we had was determining heading of a person. Though we tried, we could not find any pre-trained model that could tell us the orientation and direction of movement of a detected human. Thus, we created a rudimentary but effective system of center points, where current location and patterns of movement of bounding boxes were mapped mathematically into different scalars that could be used to determine heading and positioning, and as a result, whether a person was leaving or entering the room. If you are looking for a more detailed explanation of the logic or methods shown in this program, feel free to contact me at my email, liampilarski@gmail.com, or check out my dev post, where the AIDistance repository is linked. My profile is 22pilarski_L. With the basics out of the way, now is a good time to give a demonstration of this program's capabilities. Take a look at the dashboard on our website. As you can see, all the locations are currently empty according to our program. Kroger's is currently the location configured to be updated by our program. Let's run this demo and see how these numbers change. Hopefully you made note that two people walked in the frame, and only one person walked out, for a net movement into the room of one person. Let's see how our website updated when we refresh and re-pull the data from Firebase. You can see that the update is indeed reflected in our website. For a refresher, you can look at the output log from the command line as a second source of verification. This is the AI component of AIDistance. I hope you enjoyed. Thanks for watching.